The Jurassic period, also known simply as the Jurassic, may be one of the most fascinating eras in Earth's history. After watching the famous film Jurassic Park, the average person might think the world was filled only with dinosaurs like T-Rex. But in reality, that's not quite true. Although the Jurassic is often called the Age of Reptiles, it was, first of all, the second period of the Mesozoic era. Long and complex. It began about 201.1 million years ago and lasted around 56 million years. The name Jurassic comes from the Jura Mountains of Switzerland and France, where the first fossils were discovered and studied. The Jurassic is divided into three epochs. The first epoch, from about 201 to 174 million years ago, is called the Early Jurassic. At that time, life was recovering from the Triassic-Jurassic extinction event, which wiped out about half of all animal species on Earth. The warm, humid Jurassic climate helped life rebound quickly. Warm seas and oceans teemed with ammonites, belemnites, fish, and marine reptiles. On land, reptiles including dinosaurs rapidly occupied the ecosystems left vacant by the earlier extinction. Before long, in their evolution, some reptiles developed wings and took to the skies. The early Jurassic marked the golden age of reptiles. With hundreds of dinosaur species appearing worldwide, they lived on all 6 continents including Antarctica. Some reached incredible sizes and proportions, while others evolved into bizarre and fearsome shapes. And still, these reptiles from 200 million years ago remain one of humanity's greatest mysteries. The dinosaurs of the early Jurassic are among the most fascinating chapters in Earth's distant past. At that time, the supercontinent Pangaea began to break apart into separate landmasses. Shallow seas gradually filled the gaps, and the continents began to take their modern shape. Rifts deepened, separating Africa from Australia, while the Atlantic widened between Africa and the Americas. Lowlands formed across Europe. In places like Germany, the UK, Paris Basin, Spain, and Siberia. The Arctic Ocean also lapped the northern shores of Laurussia. Meanwhile, in North America, the Rockies and Andes began to rise. The movement of tectonic plates was accompanied by intense volcanic activity, releasing huge amounts of CO into the atmosphere, enhancing the greenhouse effect. Jurassic climates were 5 to 10 degrees with Celsius levels warmer, 4 times higher than today. Rainfall was also heavier and more intense compared with the late Triassic. Across the land, tropical and subtropical climates humid and lush. Vast areas were blanketed in green vegetation, dense forests and towering trees. The flora was dominated by ferns, cycads, and conifers without flowers. Unlike animals, plants were luckier, as there's no clear evidence of major plant extinctions at the Triassic-Jurassic transition. Thanks to high temperatures and moisture, the forest canopy grew tall and massive. Cycads were common plants in tropical and subtropical regions, and their golden age began in the Jurassic and Cretaceous periods. They reached their peak diversity in the early Jurassic. The cycad, also known as cycad, has a shape so similar to a palm that the famous botanist Linnaeus mistakenly classified as a type of palm. There was also the ginkgo tree, growing in temperate climates. Its fan-shaped leaves set it apart from all other plants. However, only a single ginkgo species survives today. Ginkgo biloba. Alongside cycads and ginkgo, prehistoric conifers also thrived. These trees resembled modern pines, firs, and cypresses in the late Triassic and early Jurassic. They changed rapidly and became more diverse. In East Asia, *Podosomites*, an extinct genus of conifer dominated. Unlike most modern conifers, *Podosomites* had broad leaves like typical deciduous trees. Seasonally. This rich vegetation created ideal conditions for an explosion of animal life, especially insects. There's no sign of insect extinctions during the Triassic-Jurassic transition. As a result, the forests, grasslands, and riverbanks of the Jurassic teemed with insects. Picture this: dragonflies skimming over the water in search of prey, beetles feeding on plants, and spiders and scorpions lying in ambush. Around this time, the first butterflies appeared. Though they weren't as colorful or showy as today's species, there were also creatures that looked like modern butterflies. But in fact, they weren't butterflies at all. This is explained by a remarkable evolutionary phenomenon called convergent evolution. In the Jurassic forests, these false butterflies flew, and even pollinated just like real butterflies, but actually belonged to a completely different order, more closely related to modern caddisflies. At that time, flowers had barely evolved, consisting only of small, primitive blooms, not yet adapted to insect pollination. However, gymnosperms, like conifers, produced cones with nectar that attracted these Jurassic false butterflies. Convergent evolution is when unrelated similar traits to adapt to the same environmental pressures. It explains why species from different places can end up looking almost identical. A classic example is the tenrec of Madagascar. From a common ancestor, tenrecs evolved into many forms that resemble shrews, hedgehogs, and even otters. If you placed a tenrec next to a hedgehog, you'd struggle to tell them apart. But in reality, the tenrec is more closely related to elephants than hedgehogs. Similarly, the Jurassic false butterflies had broad, scaly wings with camouflage just like real butterflies, but belonged to a completely different lineage. Examples like these show that evolution often finds the shortest, most efficient path. This also means that if one day we find a distant planet with Earth-like conditions, we might encounter alien creatures that look strangely familiar. By this time, amphibians were giving way to reptiles. Many species went extinct, leaving only primitive salamanders, frogs, and limbless, worm-like caecilians. These survived. Among the large amphibians, a few temnospondylus remain. Some grew up to 3 meters long. A specimen found in Lesotho, Africa, is estimated to have reached 7 meters. In all of history, the Prionosuchus was the only truly giant amphibian, but it appeared and vanished in the Permian period. Its body was flattened, with a head shaped like a paddle. Their jaws bristled with razor-sharp teeth, designed to tear into prey in an instant. Though they flourished in the early Jurassic, their numbers slowly declined. Meanwhile, reptiles were surging ahead. Before dinosaurs emerged as a distinct group, the diversity of reptiles increased rapidly in both number and form. They soon dominated the waters, the land, and the skies. True leviathans prowled the warm, tropical seas of the Jurassic. They were fearsome, yet wondrous in their own right, and impressive in every way. Having survived the Great Extinction at the end of the Triassic, they recovered and thrived once more. Among the most remarkable were the ichthyosaurs, the fish lizards. Many different species of ichthyosaur existed, averaging between 2 and 4 meters in length. But in favorable seas, some evolved to truly gigantic proportions. The largest known, Shonosaurus reached 15 meters. The undisputed giant of them all, Shastosaurus, grew up to 21 meters long. Some ichthyosaurs bore extraordinary features, with bodies like sharks, but heads like Indian gharials, their snouts long and slender. They seemed almost like nature's strange practical joke, not unlike today's platypus. One striking trait of ichthyosaurs was their enormous size, protected by a ring of bone, allowing them to hunt at night and dive to great depths. Some eyes measured 25 centimeters across, granting vision at depths of 1,600 meters, where humans would see only total darkness. By comparison, 600. At depths of 800 to 950 meters, light is just 1% of what it is at noon on the surface. Even so, while reptiles ruled land and sea, in the skies, pterosaurs had emerged in the late Triassic and became common in the early Jurassic. Though some species vanished, the long-tailed ramphorhynchids continued to thrive. They fed mainly on fish and small animals. On land, Jurassic reptiles were more diverse than ever. Prehistoric turtles closely resembled those of today, but the undisputed rulers of the land were dinosaurs. Paleontologists have identified over 900 genera and more than 1,000 species of non-avian dinosaurs. In the early Jurassic, dinosaurs rapidly filled the vacant ecosystems left after the extinction event. There's a common misconception that all dinosaurs were gigantic. In reality, they came in all shapes and sizes. Some were no bigger than a chicken, while others grew into towering monstrous behemoths. Most dinosaurs were carnivores, hunting to survive, while some herbivores moved slowly, trampling the ground and grazing on lush vegetation. Around 180 to 0.7 to 170 for 0.1 a unique herbivore roamed the region we now call Zimbabwe. Vulcanodon asterisk. It has the classic body plan of a sauropod, with thick, pillar-like legs, a long neck and tail. It was one of the first dinosaurs discovered in Zimbabwe. Its Latin name, Vulcanodon asterisk, means volcano tooth, because its fossils were found in a sandstone layer sandwiched between two ancient lava flows. At the time Vulcanodon asterisk lived, the Pepperless Formation was a hot, sandy desert, not the most hospitable place for life. Yet, there were still vegetated oases, a few rivers, and rare bodies of water. Vulcanodon asterisk measured around 6.5 meters tall and weighed to 0.5 tons. Some researchers believe it may have reached 11 meters in length and 3.5 tons, though a herbivore. Vulcanodon was not safe from the predators of its day. Evidence of its hunting emerged as soon as its first fossils unearthed. Paleontologist Michael Rath from South Africa found a tooth near Vulcanodon asterisk's pelvic bones, but its skull and neck were missing. The shape of the tooth matched that of a carnivorous predator. This suggests that the Vulcanodon asterisk may have thrashed in pain as it was causing its head to fall beside its pelvis. Such a phenomenon has been observed in other dinosaur fossils. It was because of this unusual tooth that this gentle giant was named after the very teeth of its killer. While Africa had Vulcanodon asterisk, in North America, Dilophosaurus asterisk was the apex predator. It lived between 199 and 198 million years ago in what is now Arizona, USA. A formidable killer. With high speed and remarkable agility, it hunted smaller herbivorous dinosaurs. Its name, Dilophosaurus asterisk, comes from Greek, meaning two-crested lizard, a reference to the pair of flattened crests on its skull. Scientists believe these crests were ornamental, possibly playing a key role in attracting mates, much like the wattles of monitor lizards, roosters, or modern agamid lizards. Dilophosaurus asterisk could reach lengths of up to 7 meters, 301, an impressive figure for an early Jurassic predator. In fact, it was the largest hunter of its time, earning it the nickname the T-Rex of the early Jurassic by some scientists. Though dangerous, Dilophosaurus asterisk heavily not armored dinosaurs like Coelophysis asterisk or unless it hunted in pairs or packs. For smaller prey, Dilophosaurus asterisk was a truly fearsome predator. Narrow jaws and sharp teeth allowed it to seize victims swiftly, with speed and agility. It could even snatch quick-footed dinosaurs like Dilophosaurus. Fossil analysis of Dilophosaurus jaws shows that, in the absence of large prey, it could also feed on fish and aquatic creatures, and at times scavenge carrion to survive. Coelophysis was a small, moving, swelling carnivore on 2 legs. It could reach up to 3 meters in length. Its body light and slender thanks to a hollow bone structure. It is among the earliest known dinosaurs in the fossil record. Its name, Coelophysis, from its extremely lightweight bones, hollow limb bones, that aided its speed and agility. It lived from the late Triassic into the early Jurassic, about 228 to 200 million years ago. By some estimates, 208.5 to 198 million years ago. This reptile was common in North America, especially in present-day New Mexico, and also in South Africa and Zimbabwe. Compared to the much larger Dilophosaurus type, Coelophysis just 3 meters long, 1 meter tall, and weighing around 30 kilograms. Coelophysis were typical of carnivorous dinosaurs, curved backward and sharp, with fine serrations on both front and rear edges. Although a predator, its hunting strategy differed from that of the larger Jurassic hunters. Rather than stalking alone, it often hunted in packs. In the late Triassic and early Jurassic, North American valleys were mostly desert, but green oases still dotted high plateaus, mountains, and hills. It was in these areas that herds of Coelophysis would chase and encircle their prey. Scientists have hypothesized that they may have used distinctive sounds to coordinate hunts, a primitive form of group hunting strategy. It's possible Coelophysis could even bring down larger herbivorous dinosaurs. However, its main diet consisted of small animals, reptiles, and lizards. Fossils of Coelophysis are often found alongside the remains of small animals, indicating it mostly hunted prey smaller than itself. An intriguing chapter in Coelophysis research is that for many years, it was thought to be a cannibal. This idea came from fossils found at Ghost Ranch, New Mexico, where scientists discovered the remains of Coelophysis inside the stomach of an adult. However, in the early 2000s, this theory was disproven. Later studies revealed that the small skeleton actually belonged to another species, Hesperosaurus, a small contemporary reptile. This meant that Coelophysis was not a cannibal, as once believed, but merely hunted other small reptiles to survive. Ghost Ranch was not only where many Coelophysis fossils, but also one of the richest sites for prehistoric dinosaur and crocodile remains. It is home to a massive graveyard filled with Coelophysis prompting scientists to ask, what happened here? Although the exact cause remains unclear, some theories suggest a natural disaster such as flooding or drought may have wiped out entire herds of Coelophysis, burying their remains together over time. Another small but notable dinosaur of the early Jurassic was Lesothosaurus. Its name comes from the country of Lesotho in Africa, where its first fossils were found. Lesothosaurus lived around 199 to 198 and was one of the smallest dinosaurs of its era. It could grow up to 2 meters in length. The upper size estimate. Height estimates vary widely, ranging from 40 centimeters to over 1 meter. Its weight also ranged broadly, from 3 to 10 kilograms. This is understandable, since we are not referring to a single species, but an entire genus. Lesothosaurus moved on to long, allowing it to reach remarkable speeds. Its small, 5-fingered forelimbs were well developed, and from the side looked like a miniature version of a human hand. Like a human's little finger, its 5th digit was underdeveloped. These forelimbs allow Lesothosaurus to reach and grasp the plants it fed on. Its diamond-shaped teeth were arranged in rows along its jaws. At the front of the upper jaw were 12 pointed teeth shaped like arrowheads. This light, sharp structure was not suited for grinding tough food, but ideal for slicing soft stems and leaves. Its body was slender and lightweight, somewhat resembling its ancestor Stegosaurus, an ancient reptile that had only just begun to walk upright on two legs. Its long, strong tail helped it balance while running at speed. With its short skull and elongated body, Lesothosaurus looked much like a two-legged lizard darting across the ground, a feat still performed by some modern reptiles today. A quick and agile animal, it would flee at the first sign of danger. Did it have predators? Of course. At least one hunter. And when naming typical prey for Coelophysis, Lesothosaurus fits perfectly. Coelophysis long could easily outrun Lesothosaurus. The latter had no defensive weapons, no sharp claws, no armor plating, and no fangs. Another small yet fascinating dinosaur was Larinus, a species with many peculiar features that have puzzled paleontologists. Its Latin name, comes from the Latin words meaning vole face, a reference to its sharp canine-like teeth found in the fossilized jaws. Yet the rest of its dentition suggests it was a plant eater. Larinus lived in around 199 to 196.5 in what is now the Republic of South Africa. It grew up to 1.2 meters long, stood about 50 centimeters tall, and weighed up to 10 kilograms. It moved bipedally, like its close relatives. Strong, lightweight legs, paired with a long tail for balance. Well-developed forelimbs could grasp vegetation while feeding. Its skull was teardrop-shaped, with a hard, beak-like tip at the front. Just behind the beak were large, sharp canines. Because of these teeth, scientists initially believed Larinus was descended from the mammal-like reptiles, but closer analysis revealed it was in fact an omnivorous dinosaur, feeding on both plants and small animals. Its diet included tender fern stems, horsetail shoots, tougher roots and bark, and occasionally insects or small vertebrates. Despite its sharp canines, Larinus was no fearsome predator. When attacked, it could bite back, but relied mainly on speed and camouflage to evade predators. Many still imagine all dinosaurs as giants, but that was far from the truth. Many species were no bigger than a chicken or a lizard. Take Adenilosaurus, a small dinosaur about the size of a turkey. It would take over 100 million years of evolution before the giant herbivores emerged. If we have already met the great predator Dilophosaurus, then to see the giant plant eaters, we must travel to Laurasia, to what is now China. In Yunnan province during the early Jurassic, around 203 to 168.3 million years ago, a massive herbivore roamed that bore the region's name. Yunnanosaurus. It could reach 13 meters in length, stand for 0.3 meters tall, and weigh up to 3 tons. Much smaller than the behemoths of later eras, which weighed tens of tons. But in the early Jurassic, Yunnanosaurus was considered a giant. It moved mostly on all fours, but could rear up on 2 legs for extended periods, to reach high branches, or to raise its forelimbs in threat against predators. Its forelimbs were large, resembling the hind limbs, and ended in formidable claws at the end of its long neck. A small, tapering head. Its most striking feature was more than 60 spoon-shaped teeth. When the mouth closed, these teeth pressed tightly together and self-sharpened, allowing it to strip leaves with ease. Remarkably, this trait was rare among primitive dinosaurs such as Yunnanosaurus, later seen in colossal sauropods like Brachiosaurus. This is a prime example of convergent evolution, where unrelated species develop similar traits because they inhabit similar environments. Had scientists found only the teeth of Yunnanosaurus, they might have mistaken it for a later herbivorous sauropod. Yunnanosaurus moved from grassland to grassland. Its diet far from selective, thanks to its unique dentition. It could strip leaves from tall trees or feed on low ferns and horsetails. It likely lived in herds, gaining safety in numbers against predators. The same strategy seen today on the African plains, where herds of buffalo can drive off even lions when they stand together and fight back. By the close of the early Jurassic, the Earth began to cool. Some regions were touched by ice, but not enough to trouble most mammals, whose fur and burrows kept them safe. For dinosaurs, however, the chill was a harsh test, for they thrived in warmer climates. Not all would survive the cold. For instance, Coelophysis, a small, nimble predator, failed to adapt and vanished. Even so, the early Jurassic teemed with remarkable reptiles, of which we know only a fragment from the few fossils that endured millions of years.